Hello, how do we simplify this problem? Solution. Let's suppose we have square root of 17 plus 12 root 2 equals square root of x plus square root of y. Suppose we take square of both sides, so we're gonna have square root of 17 plus 12 root 2 all squared equals square root of x plus square root of y, everything squared. This bigger square root takes care of these two. So we are left with 17 plus 12 root 2 equals. So let's expand this guy. So we're going to have square root of x plus square root of y times square root of x plus square root of y. So we're going to have 17 plus 12 times square root of 2 is equals to square root of x times square root of x, that is x, plus square root of y times square root of y, that is y, plus square root of x times square root of y, that is square root of xy, plus square root of y times square root of x, we have square root of xy. So we have 17 plus 12 root 2 is equals to x plus y plus, when we add these two guys, we get 2 times square root of xy. So now, let's compare the coefficients. So comparing coefficients, when we compare the coefficient, we're going to have x plus y to be equal to 17, and this guy 2 times square root of xy equals 12 root 2. So let's simplify this guy. 2 here 1, 2 in 12, that is 6. So we are left with square root of xy equals 6 root 2. So squaring both sides, we're gonna have square root of xy all square is equals to 6 root 2 all square. So this takes care of this. We have xy is equals to, that will be 6 square times square root of 2 all square. So xy is equals to 36 into 2. Xy is equals to 2 times 36, that is 72. So let's call this equation 1 and let's call this equation 2. So combining the two equations, from equation 1 we have x plus y is equals to 17, and equation 2 we have xy is equals to 72. So this is equation 1 and this is equation 2. We can now solve for x and y. From equation 1, when we make y the subject of the formula, we have y is equals to 17 minus x. So let's call this equation 3. We can now easily substitute equation 3 into equation 2. So we're going to have x into 17 minus x is equals to 72. So let's open this bracket. X times x, that is 17x. X times negative x, that is minus x squared, is equals to 72. Rearranging this equation, we're going to have x squared minus 17x plus 72 is equals to 0. This quadratic equation is factorizable, but when you factorize this guy very well, you are going to get x minus 8 times x minus 9 equals 0. This implies that we have x minus 8 equals 0, or x minus 9 is equals to 0. So x is equals to 8, or x is equals to 9. So we obtain two values for x. So now we are going to consider each case when x is equals to 8. So that's the first case. Let's call it case 1. When x equals to 8, what do we have for y? We are going to plug it into equation 3. So this is our equation 3. We're going to have y is equals to 17 minus 8. So our value of y is equals to 9. So that means when x equals to 8, we have y to be 9. That's the first solution. Now for the second case, case 2. When x equals to 9, what do we have for y? We are going to plug it into equation 3 again, this equation. So we're going to have y is equals to 17 minus 9. So y is equals to 17 minus 9, that's simply 8. So x comma y is equals to, when x is 9, we have y to be 8. So which is the second solution. Now back to our supposition. That is this guy. Therefore, square root of 17 plus 12 times square root of 2 is equals to square root of x plus square root of y. So when x is equals to 9, we're going to have square root of 9 plus square root of when y is 8. So this equals square root of 9, that's simply 3, plus square root of 8 could be written as square root of 4 times square root of 2. So this gives 3 plus square root of 4, that's just 2, times square root of 2. So square root of 17 plus 12 root 2 is equals to 3 plus 2 root 2, which is the required solution. So that's it. Thanks for watching. See you in the next video.